Hi everyone. So in this video we're actually going to find the derivatives of every single exponential function. Now an exponential function is denoted by e to the x. So anytime you ever see e to any power, you're pretty much going to have to find a derivative of that. Now the one thing that's pretty cool about e to the x is actually pretty simple. The derivative of e to the x is exactly e to the x times the derivative of whatever the exponent is. So once again, whenever you have to find the derivative of e to the x, it's literally e to the x times the derivative of whatever the exponent is. Alright, let's go ahead and do a couple problems. Well, the first thing we're going to notice is, if y equals e to the 3x, find y prime. Well, I notice it's e to the 3x, so I know that my derivative is going to be e to the 3x times the derivative of the exponent. Well, the derivative of the exponent 3x is just 3. So this answer is just y prime equals to 3e to the 3x. And that's my final answer. Okay? Let's do a couple more. So now this time there's a constant in front of the e, and also there's an exponent. Well, it doesn't really matter because remember, a constant we just keep it to the end. So when I have to find this derivative, y prime is going to equal to that constant, that 3, times, since it's e, just drop it down. E to the 5x squared minus 1 times the derivative of the exponent. Well, if the exponent is 5x squared minus 1, that derivative is 10x. Well, because there's a 3 and a 10 on the outside, I want to multiply them. So y prime is equal to 30x e to the 5x squared minus 1. And that's my final answer. So anytime you have to find the derivative of e, it's literally bring it down times the derivative of the exponent. So now let's make it a little bit more complicated. Well, in this case, I can't just forget about this x cubed because this x cubed is an actual function. And when I have a function times a function, that means the only way to actually find its derivative is product rule. So with product rule, we know that this is our f, this is our g. This is my first equation, this is my second equation. So bring down the first, derivative of the second. Well, the derivative of e is bring it down, e to the 3x, times the derivative of the exponent, which is 3. So bring down the first, times the derivative of the second, bring down e to the 3x, times the derivative of the exponent, plus bring down the second, e to the 3x, times the derivative of the first, which is 3x squared. Then simplify things. This will give you 3x cubed e to the 3x, plus 3x squared e to the 3x. And that's what y prime equals to. So if you ever happen to see that the equation in front of e happens to be an actual function and not just a constant like the previous problem, that's going to mean it's product rule. So bring down the first, derivative of the second, bring down the second, derivative of the first. And for our last problem, we can't forget that in calculus there's extremas, the first derivative test, concavity, increasing, decreasing, concave up, concave down. These are still things that we actually have to apply even though we're working with e now. So in this case, they want us to find an extrema. So remember, extrema always means pretty much y prime equal to 0. So I'm going to go ahead and find this derivative. And we'll notice it's a function times a function. So the only way to solve that is by product rule. Bring down the first, derivative of the second, which is e to the x, times the derivative of the exponent, which is 1. So I'm just going to leave it like that. Plus, bring down the second, derivative of the first, which is just 1. So I'll just leave it like that. I won't put times 1. So now, I have x e to the x plus e to the x. That's what y prime is equal to. But my goal is I want to find my extrema, so I have to find critical numbers, so I have to set this equal to 0. Now this is the part that a lot of people get confused because how do we even solve this? Well, we can't forget about what we learned in algebra. Whenever they have something in common, we want to take it out. So hopefully you notice that they both have a common e. So because of that, you want to factor out that e to the x. Well, what am I going to be left with? Something that I do is I like to put my whatever I take out, my GCF, on the bottom of the fraction, so I know that this is going to cancel out, which gives me an x, and this is going to cancel out, which gives me a 1, equals to 0. Then my next step is set the inside equal to 0 to find my critical numbers, and I'm going to get e to the x equals 0, and x plus 1 is equal to 0. So then I'm going to go, well, how do I solve for e to the x? How do I get that x alone? Remember, the only way to get rid of e is by multiplying both sides by ln. So pretty much ln e to the x equals to ln 0. Now ln and e cancel out, which just leaves me with x equals 2, but when you type in ln 0, that's actually undefined. So that means there's no real values for e to the x equaling 0, so there's no critical numbers. So now my next step is x equals to -1, and that's the only critical number I have. So now my next step is, well, I gotta set up my number line, because when you find critical numbers and you want to find extremas, you have to put all your critical numbers on the number line, put your boundary points, pick a number less than, pick a number greater than, and where do we plug it in? Well, because we're testing for extremas, that's max and min, which means first derivative. So we're going to plug -2 and 0 into our first derivative, which is this factored one. Well, now let's think about it. If I plug in -2, it's e to the -2 times -2 plus 1. Well, e to the -2 is just going to give me a positive number. But -2 plus 1 will give me a negative number. Well, positive times a negative gives me a negative, which means that I am decreasing. Well, let's look at 0. E to the 0 times 0 plus 1. E to the 0 is just 1, because anything to 0 is 1. 0 plus 1 is 1, which gives me a positive, so that means it's increasing. So that means that I happen to have an extrema. Because I'm decreasing and I'm increasing, that means that I'm going to have a min at -1. So now I know there's a min at x equals to -1, but they want me to find my extrema, so that means I actually have to find my real point. And because I have to find my real point, that means I'm going to plug my extrema, my critical number, into my original equation, because that's going to give me my real point. So now I'm going to find f of -1, which equals to -1 times e to the -1. So this answer is just going to be pretty much 1 over e. And because it's 1 over e, well, that just means that your final point, your min, occurs at -1, comma, 1 over e negative. And that's your final answer. So in case they ever happen to ask you to find extremas, find critical numbers, find concavity, same exact concept. You have to find your first derivative, but now in this case you're always going to have to factor out an e. So if you ever notice you have an e in common, take it out. What I like to do is put it on the bottom, simplify, and that's pretty much it. Alright guys, thanks for watching.